Hello and welcome back. Today I really found something special. At least I have never seen one before, and it was the first time I found it on eBay, and immediately, of course, I put my bid on it. And it is the Keithley multimeter. It is the Keithley 167, and it is a probe multimeter. And it is from 1972. At least I found an ad. In that time, the cheapest model, I don't see what was the difference between the cheap and the expensive model, but the cheapest model was 325 at that time. And it can measure from 1 millivolt up to 1000 volts DC and up to 500 in AC. And its input is 55 max, which is a lot, so it's high impedance. So here it is close by. Yeah, and it just have simple functions: AC volts, DC volts, ohms, and off. And looking at the switches, it has been always in the AC setting, and it is quite dusty. And if you wonder where is the display, well, the display is actually in the probe. And then you wonder maybe why is it called a probe meter? Well, you can just pull this out. Look at that, and then you have your probe. And then you undo the probe, and then you have, I would say, at least 50 centimeters of cable, and then it makes sense to probe, and you can immediately have your readout while you're probing. Well, it is a bit old, and it seems it's all loose, but maybe it is just still all working. It is usually battery powered, but I think you need 6 D cells, so it's a lot of battery. But you can also power it from the DC in the back. So it's 3 pins here. One is ground, one is the battery itself, so you can measure your battery, and the other pin is the external power. And I think, just like with the old Temblies and all those battery operated multimeters, it probably is usable between 7 and 15 volts. And but one thing is missing, and that is there should also be a ground wire, because if we probe here, of course you need the other potential, and that you put from the lower. But the cable is even longer. Wow, how much cable is there? Oh yeah, up to here. Well, that's almost a meter. Well, before I power it on, I think I will just try to open it. Well, I just measured the probe cable, and it is even more than a meter. It is 130 or around 50 inches. So, and that is quite a bit. And I hope there is no break in the cable. Well, the probe is a little bit loose. Maybe it just needs to click, and it just doesn't click. So we can have a look at that. I can carefully glue it when I know it is working. And well, the switches are probably, it is all very dirty. And then the switch always have been in this position, because if you look, you see the dirt right there. It always has been in this position. Yes, okay. Battery compartment. Indeed, 6 D cells. That, yeah, it looks a bit leaky, but we don't need to use the batteries. But we can still clean that up. And how long you can work with those batteries. 3 months battery life. Well, it doesn't specify how many hours you're actually using it, but that seems a lot. Well, it is a lot of capacity. I'm not sure if this is actually, I see here there is a screw, so maybe you can unplug. Okay, it doesn't seem to turn. I'll leave that as it is. Let's go a little bit further. Look like this. Yes. Okay, adjustment screws. It is a shielding with the spring here. It is already a revision F, so it is probably a little bit later than the first one from 72. Yeah, I think this is some sort of a plug. Well, here is that probe socket, and it seems to be that it is just, it really looks like an IC socket where the probe is connected to. But it looks like I can pull it from its socket, so I'm carefully going to try to do that. Because the PCB needs to be taken. Yeah, there it goes. It is indeed a sort of an IC socket, and it does go. So I was able to create some length in the probe cable, and now I carefully want to just take the PCB out so we can start cleaning. But first have a look at all the components. Most of my viewers will say, you need to change all the caps. Well, if you view my channel a bit more, you know I only do that when it is really, really necessary. Okay. Wow. Well, I removed the probe so we can have a better look on the circuit. I did see somebody has been working on this already. They cut here the capacitor, so maybe they expected it was shorted, and then they soldered it back. They didn't do a really good job. And also I found that the soldering here where the probe was connected was also not that good. I don't think that is a good sign. But if you look at all the components, it almost looks like it is made of gold. They really do use nice components. They really put some attention in those days. Now yes, somebody definitely work on it. Here you can see that there has been some soldering done on the IC. I see some soldering done here, and I didn't remove the flux. So before I'm gonna do anything else, I just want to be sure if it's working or not, because maybe it's just working and I'm just worrying about a lot of things. So I'm putting my power supply and I set it to 9 volts, and I put the current limit at 10 milliamps just to start. And I have no clue how much power it takes. It runs on battery, so I expect it not to use too much. But on the other hand, it also had these huge D cells. So I will just try. Let's have a look. So I have it switched on, and I thought that the probe was loose. No, that it was not good. It is actually loose, but it turned out to be a switch. So you need to switch it on. As you already can see, the power supply immediately goes into the current limit, and we don't see anything in the display, but I saw a quick blink. Have a look. So shortly at the blink, because the display of the multimeter is actually the probe. So what I will do a little bit more. Just put 200 milliamps. Yes, and we have a readout. I don't know, I will switch off the light. I don't think it's visible. Let's try again. Here it is. We have a readout, and I think this is usually it is in ohms, as you can see, because there is a little stripe there. So if I connect it here, oh yeah, this is 0 ohms. Here you can see the ohms are selected, and let me just short it. So the ohms measuring seems to work pretty cool. And if I let go of the probe, it switches off. And if I put, it switches back on. So that's pretty cool. I'm not sure if also the voltage works, but the ohms is usually the most difficult one also because the switches get dirty and everything, but that one seems to work. I didn't really try a real value, but at least to see the difference between endless or 0 ohms. And now I'm going to try to do DC voltage, and usually I don't use this one, it's the Veneersy. But because it has crocodiles, it now suddenly becomes nice. Because the other one is crocodile, so let me see if I still remember how this works. Let's try 1 volt first. Input is on, okay. It is a bit complicated, this thing. Let me first set it to DC voltage, that is the second one. Yes, it says 0. Put this one on the probe and this one on the ground, or at least the meter ground reference. And let's see if we have 1 volt. You have almost 1 volt. Switch off the light again, have a look. This should be like 1 volt and it says 0.89. Let's put a little bit more, and it's even auto 2 volts. Yes. 5 volts. Cool. And then that is pretty cool. Well, I connected my DMM Check Plus, and that one also can do AC, and it should be around 5 volts. And if I check, it is 4.43. Well, it is not a true RMS meter, but I'm checking only now on 100 Hertz, but the square. If I switch it down and I switch it up again, I now go to 10K, I think. And 10K doesn't like. It just now doesn't make sense. Put it back to 100 Hertz. 4.4 volts. So there is some work to be done there. I'm putting it back now to resistance, and I also have some 1% resistors, and this should be 100 ohms. And it says 104. If I go to 1K, look at that, that is 1K. 10K, 100K, look at that, super cool. So it seems all to be working fine, only not for the AC. Maybe that's just adjusting, or it's cleaning the switches. I haven't cleaned the switches yet, and still the resistance was good, but we've been measuring very low values, and the input impedance of this probe meter is like 55 mega ohms, and usually the multimeters are like 10 mega ohms. So a little bit of dirt, I think, doesn't even bother the meter too much, because it's already that high impedance. But I will clean it, and maybe we get the values a little bit better, and maybe I can even find where I can adjust the AC, that at least on the 100 Hertz that it is correct. But so the person that worked on it actually did fix it for me. Cool. So I managed to put it all back together again, and we're gonna do some testing. Well, if we insert the probe inside this original home base, then it acts like a normal DMM. So if you short, you will see a short. Let's add 2 volts to it. Look at that, almost 2000 counts. And I have here the 10 volts, so I don't need to beep, 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 beep. Add 10 volts right there. And for AC, I can just plug it into the mains. Okay, so switch it to AC mode. Yes, here we go. I put it in the, and here it is, 233. Perfect, that works. Try the ohms settings. Oh. Yes, 100 ohms. Here we go, 100. 1K. There we have it. 10K. There we have it. And 100K. There we have it. So it is actually a probe multimeter, so that means we're going to use the probe and just take it out. So let's see how the probe works. Well, originally it's supposed to be a cable like this, and that also fits exactly here in this compartment, and that is because you need your ground. So if we go to ohms mode, we switch it to ohms, we switch it to the ohms mode, then we put the ground wire to one side and we have the probe on the other, and then you squeeze the probe and then it should say 100, or we go to 1K. 1K, and then it automatically switches off if you don't squeeze. 10K, push the probe, here we go. I hope you can see the display. Well, and the same is for if you measure voltages. So let's see. Here we go. So you can actually probe your circuits. And the nice thing is, I mentioned before, it is not like the normal multimeters that it is 20 mega ohms impedance. This one is actually 55 mega ohms. So you really have almost none influence when you're probing. So let's have a look at the results so we know it's all working. I did clean a lot the cover, and its original color almost came completely back. The dirt is of course gone everywhere, and I try to restore it as good as possible. And well, only the extra I did is put my power cable there, because I don't have a connector like that. And it all looks a lot better. And switch it to the ohms. I have here my dimming load, so just put it in. It is small, but if we can zoom, it is pretty nice to read. Wow, that was just unbelievable. 1972. I've never seen one before, and when it arrived it looked terrible, but it is almost 50 years old. After a good cleanup, I didn't even adjust anything. It was just like the values as it were, because I thought, maybe I'm going to calibrate it, but then I thought, no, let's just put it together and see what the values are. And it doesn't look bad. Amazing. Nice quality product, and I like the idea of the probe. So happy with the result. Thank you for watching, and I hope to see you next time.